Hi and welcome to IMS. I am Navneet Kataria and I'm the Product Marketing Manager for Anritsu benchtop product line. We are in booth number 547 and we are showing a lot of new technology and new products which are launched this week at IMS. One of the main products that we are focusing this time and launched this week is the ME7869A PhaseLync system. It's basically a distributed modular two-port VNA that can make vector-corrected S-parameter measurements over distances as long as up to 100 meters. So in traditional VNAs, what used to happen was you had two ports of the VNA in the same box, in the same chassis, so that the synchronization between the two ports can happen. However, for testing large cables and large aircrafts or ships, long distance measurement, especially also for antenna customers, what they had to do was they had to use a high dynamic range VNA and then use external coaxial cables that would go at the end of the cable at say one antenna and the other one which is really far off, maybe say 30-meter distance. And for doing that, they had to use these RF coaxial cables, and if the cables would wiggle a little, then the phase would be really problematic, and that created a lot of problem. So what we did at Anritsu, we got this new technology which is called as the PhaseLync technology, and we were able to actually, instead of a benchtop two-port VNA in which you have the two ports right into the box, we cut the VNA into two and we separated the two ports of the VNA actually by a distance right up to 100 meters. So what we are showing here are these two, the heads of the VNA with the two ports. Now let me just quickly disconnect the two VNAs, and basically what you can do is you can have these two VNAs now separated over longer distances right up to 100 meters. The good thing about this solution is that you don't need separate power cables for the VNA heads. And what you're seeing here is these are the two VNA heads, and that is basically the control module, which is the PhaseLync control module. That module actually serves many purposes, but the three main purposes of that PhaseLync control module is number one, to supply or act as a router for the synchronization between the two ports for the LO and all. Number two, it also supplies power to the two VNA heads. So if you are spacing the two VNAs right across the distance of 100 meters, you don't need additional power supply or a separate power supply. The third and the most important thing that the phase control module does is that it connects the hardware to the software which is running on the Shockline VNA. Right now, since the two ports are not connected, you can see the traces are not looking that good. However, if I connect the two ports back on, you will see that the S21 trace and S11 trace are really good. So this is the advantage of the modular distributed two-port VNA, and on the right you can see we do a lot of testing of large vehicles, automotive related application, antenna measurement, ships. On the ships, you have a lot of waveguide components that you need to check for leakage. On aircrafts, because aircraft has really a wide wingspan and there are antennas at the wings and they carry a signal through a coax cable to the cockpit. So you have to make sure that there are no leaks in those coaxial cables, and those coaxial cables could be really, really long. Again, the solution till today was to use a benchtop VNA which has two ports inside the VNA and then have long and lossy phase instability causing cables. We actually make sure that you get the best product with the latest technology for making your life on the measurement side very easy and simple to use. The information is available on our website. This is the new PhaseLync enabled two-port distributed VNA called ME7869A. I hope you liked the demonstration, and thank you so much for watching.